I am Krishna with my CWID 503257227. I would like to share my screen and introduce my today's topic. My today's topic is my microkernel based operating system. I would like to go with the introduction. A computer's boot program loads an operating system which controls all other softwares and apps. It also permits a software to communicate with hardware on the computer, and application programs communicate with the operating systems, which is known as API, through a specified application program interface to seek services. Every computer requires at least one operating system to function in order to run the additional programs. Operating systems provide a platform for the user face and also with application space to run the programs. Additionally to this, because the microkernel only controls the processes and memory, if a user processes breaks, it won't compromise the stability of the entire system. In particular, the operating system provides an isolation and security and manages the allocation and the deallocation of the computational resources and encapsulates the complexity of the hardware. Memory management and resource management, process control, and input connectivity, security, and stability are just a few of the many duties that very kernel does. Actually, what is an MBOS? Microkernel based operating system refers to an operating system architecture that uses a microkernel design. The microkernel provides a reduced set of fundamental ideas and methods for managing system resources. The kernel of an OS, which manages the system resources, is an essential part. It also acts as a bridge between the hardware and the software of the computer. It also determines the frequency and duration which software makes use of a given piece of hardware. It does not impose many rules, which makes it possible to add more operating system components. All of a fundamental system functions like a process management, memory management, input communication, interrupt handling, and file, etc., are managed in kernel space by Catholic kernel. The operating system is composed of numerous connected operating that make up a sizable executable binary software. I would like to introduce with the history of MBOS. In 1967, Microkernal was installing RC 4000 prototype in the Jaklady Autowi Puławy fertilizer plant in Poland. Brinch Hassan and his team became concerned with the lack of generality and reusability of the RC 4000 system. Its nucleus provides the inter-process communication based on a message passing for up to 23 unprivileged processes, out of which 8 at a time were protected from another. This strategy was to be implemented by the hierarchy of running programs, in which parent process has complete control over the child processes, acted as their operating systems. Besides these elementary mechanisms, it has no built-in strategy for program execution and resource execution. The design and the implementation, by keeping kernel services in kernel address space and user services in the user address space, the size of kernel and the operating system as a whole is reduced. Message passing, which slows down the microkernel execution, is used to establish the communication between client programs and applications and services execution in user space. L4, QNX, and NIX are a few examples of operating systems with a microkernel base. As you can see in the diagram, the most important OS component, the kernel, is in the charge of providing the fundamental services. As a result, under the architecture, only the most important services are present inside the kernel. In contrast with that, the system application software contains the remaining operating system services. Users can react such pointless services within the system applicant as a result. With the interprocess communication, the interprocesses interaction is referred to as interprocess communication. Several threads that make up a process Any process threads communicate with another in the kernel space. Ports are used to transmit and also receive messages between threads. Ports like process port, exceptional port, bootstrap port, and the registered port exist at the kernel level. These ports all communicates with the user space operations. And the other one is the memory management. Memory management is the process of allocation space in many memory for processes. However, there is also a certain creation of virtual memory for processes. Virtual memory means that if a process has a bigger size than the main memory, it is partitioned into portions and storage. After that, one by one, every part of the process is stored in the main memory until the CPU executes it. The CPU scheduling. All the processes are queued and executed at one at a time. CPU scheduling aids in optimizing CPU utilization. In addition, resources are being used more efficiently. It also minimizes the waiting time. Waiting time shows that a process takes less time in a queue and that resources are allocated to the process more quickly. CPU scheduling also reduces responsible and turnaround times. Message passing. Message passing is used to communicate across various sections of the operating system rather than the shared memory. This provides a more secured and trustworthy means for the processes to share information as well as preventing faults and mistakes from spreading across the system. Extensibility, because the new services and the drivers may be introduced to user space without altering the kernel design makes it easy to add new functionality to the operating system. Security, because defects and vulnerabilities in user space codes are likely to impact microkernel operating systems that can be secure. Furthermore, formal verification techniques are frequently used in kernel based systems to confirm the validity of the kernel code. Advantages and disadvantages of microkernel architectures. I would like to go with the advantages. More secure operating system due to reduced attack surfaces, system stability as the crashes in user level processes do not affect the entire system. More modular and flexible, making it easier to customize the operating system. Simplified development process as services are developed and tested as independent user level process. Disadvantages are slower message passing between user level process and can affect also performance, especially in high performance applications. Limited performance optimization due to separation of kernel and user level process. High memory usage compared to monolithic kernel. Terms of performance and complexity. The choice between a microkernel and the monolithic kernel architecture depends on the specific needs and requirements of the operating system is being developed. More advantages and disadvantages of MBOS are reliability. Microkernel architecture is intended to be more dependable than the monolithic kernel architecture because many operating system services run outside of the kernel area and any problem or security vulnerability in a service does not affect the entire system. The flexibility. Microkernel design is more flexible than the monolithic kernel architecture because it allows for the addition or removal of different operating system functions without impacting the overall system. The fault isolation, the microkernel architecture helps to isolate problems and keep them from spreading across the system. Performance based microkernel architecture can boost performance since it limits the kernel to the core management functions. The system may become quicker and more effective as a result. The disadvantages are performance overhead. When compared to direct function calls in monolithic kernel designs, this can result in a latency and decreased efficiency. Difficulty in development. Constructing operating systems based on microkernel architecture might be more complex and than constructing monolithic kernels because of its necessities. Greater attention to detail in establishing the communication and synchronization mechanism between the various services. Higher resource usage. because it necessitates additional communication and synchronization methods between the various operating system and services. Microkernel design might consume more system resources such as memory and CPU than monolithic kernels. Lack of standardization. System services and device drivers are frequently implemented without a standardized framework or interface specification in microkernel based. QNX MBOS, real-time operating systems, which is known as QNX, is marketed and largely targeted at the embedded system sector. One of the earliest successful microkernel operating systems was QNX. Early 1980s saw the development of the product by Canadian company Quantum Software Systems, that are known as QNX Software System. As of 2022, yeah, like earlier, it is used in variety of technology, including automobiles, medical equipment, and robotics, railroads, and more also. The history of QNX MBOS is 1980s, the Gordon Bell and Dan Dodge, both the University of Waterloo students, took a course on the real-time operating system where they created a simple real-time microkernel and user programs. They moved to the high-tech plant in the city of Canada, Ontario, in the following year to create a quantum software system because they were both persuaded that there was a market for such a system. In 1982, the first release of QUNX for the Intel 8088 CPU took place. In 1984, Quantum Software System changed the name of QUNX to QNX to avoid trademark infringement accusations. The result was QNX 4 in the end. A new windowing system was developed by Patrick Hayden and Robin Bergener, were both full-time employees at the time. In the late 1990s, QNX issued to a sample image that fit in 1.44 MB 1.44 MB bootable floppy disk for the 386 PC and featured POSX compliant and QNX4 OS, a full graphical user interface, a graphical text editor, TCP or IP networking, a web browser, and a web server. The company released the QNX Monometrics Tools collection in 2002, which was a set of Eclipse plugins blended with the Eclipse Workbench. What is QNX? This is a more common monolithic kernel in which a system kernel was very large program made up of vulnerable components, each of which has own set of capabilities. The majority of the operating system is executed by a collecting of tiny jobs called resource managers in the microkernel based system QNX. Inter-process communication in QNX is sending a message to another process then waiting for a response. Control of the CPU is transferred simultaneously, skipping the CPU scheduler. If the receiving process is waiting for the message, as a result, the CPU does not lose one turns, and sending a message to another process is waiting for a reply. However, a user face implementation QNX style messaging for Linux does not exist. Most inter-processes communication approaches on Unix, Linux lack of this integration. It is not necessary for the receiving process to be running the same physical computer as the transmitter. This technique was intended to handle all input activities, file systems, operations, and network operations, and the data sent was copied during message processing. Thread priority to the prioritized message handling because input requests are handled by passing high authority receive threads in service before low priority threads, which is critical in harsh time real entry. History of QMBX is 1918. Both the QNX Neutrino RTOS 7.1 is QNX has recently developed a new real-time operating system. The QNX Neutrio real-time operating system RTOS is the heart of QNX technology, a fully featured RTOS that enables the next generation solutions in every area where dependability is critical, including automotive, medical device, and robotics. The reliability of the microkernel is failing component will not bring down the other components or the kernel. It may be resumed or promptly with a minimal performance impact. Install a new hardware or drivers which confidence that a driver failure will not result in a system failure. When services or process fail, the high availability manager can undertake the multi-stage recovery because the design and the QNX OS for safety allows you to focus on which you introduce rather than the OS which it is built. In the real time, QNX Nutito RTOS is designed to scale on the latest ARM and x86 multi-core system on a chip, which is called as SOCS, and it supports symmetric and the symmetric multiprocessing as well as bound multiprocessing. A QNX upgrade on a regular SMP or adaptive partitioning ensures that the key process they receive the CPU cycles they require. You set up the time division so the programs that want more power can obtain unused cycles from the budget of other process. Security that is a comprehensive and the layered conveniently establish the security profiles and the granularity your system require, as well as the monitor and the audit their integrity. The complete layered security strategy of QNX Neutrino RTOS enables you to install preciously the security procedures required to minimize attacks and secure your systems. Granular system privilege control encrypted and self-verifying file systems. AES 256 encryption and lockable encryption domains are used. QNX needed real-time operating systems in the cloud. Software development are hampered by hardware availability and wasteful methods. BlackBerry QNX addresses the issues by hosting the QNX Neutrino real-time operating system RTOS and QNX OS for safety. QNX is embedded real-time operating system with various benefits and downsides when they compared to the Windows or Linux. The advantages of and disadvantages of QNX. I would start with advantages. Real-time capabilities because QNX is developed for real-time systems that can handle high priority operating systems with a delay. As a result, it is well suited for the applications, including the automotive systems. The small footprint QNX has a tiny memory footprint and a low processing overhead, making it quicker and efficient than the bigger operating systems or like Windows or Linux. High reliability QNX is noted for the high degree of dependability and stability, making it perfect for mission and critical systems where downtime is not tolerated. Security. QNX is also known for its great security with a strong security model and a narrow attack surface. Disadvantages. QNX has a smaller ecosystem than more popular operating systems like Windows or Linux, which might make it difficult to obtain support of developers who are familiar with the system. QNX support restricted the number of hardware platforms, which might make it difficult to obtain hardware that is compatible with the operating system. Limited apps. When compared to Windows or Linux, QNX has a fewer programs available, which might be a drawback for the customers that want certain software tools or applications. Cost because QNX is a commercial operating system which is more expensive than the open source alternatives such as Linux. I would like to conclude my project with this micro-based kernel information. And thank you.